Welcome to the AASHTOWare Pavement ME Design Fiscal Year 25 webinar number 2 on integration and use of recycling options for rehabilitation design. I'm Hari Nair, I'm the chair of the Pavement ME Task Force, and I'll be your moderator for today's presentation. And today's presenter will be Dr. Sri Rao of Applied Research Associates. This presentation is being recorded and will be available on the AASHTOWare YouTube channel and the Pavement ME homepage. Again, see the next slide. Again, I am the chair of the Pavement ME Task Force, and Ian Rish of Georgia DOT is the vice chair. The other members of the task force are Ryan Fragapane, he's the AASHTOWare product director, Ben Said, associate product manager, Nusrat Morshad with the New Jersey DOT, Kumar Dave with the Indiana DOT, Dulce Feldman with the California DOT, Jason Simmons, Utah DOT, Robert Stodler, Maryland DOT, and we have two liaisons, Tom Yu from Federal Highway and Diana from Ministry of Transportation, Saskatchewan. She's the Canadian TAC liaison. Like Ben said, we encourage you to ask questions, and those will be addressed at the end of today's webinar. If you have questions, please click on the question and answer button to send your questions, and we will address those directly after the presentation as time permits. Any questions not answered will be responded separately. Now, Dr. Sri Rao will begin the presentation.
Thank you very much, Hari and Ben. It's an honor to be presenting in this webinar. Good morning and good afternoon, everyone who is attending the webinar. I appreciate you taking your time today to listen to this webinar and interact through the Q&A session in this webinar. We'll start off with a very quick poll on the webinar, and Ben, if you wouldn't mind, please go ahead and fire up the first poll before we get started into the main content of the webinar. So there's basically two simple questions on the poll, just mainly just to gather your affiliation and how many people are attending the webinar from your location. And I believe Ben will give about a minute or so for this poll.
Everybody, the pool. You can continue.
Okay, thank you very much, Ben, and thank you everyone again for attending the webinar. So just to kind of start off with the webinar, I'll just talk about these are not necessarily prerequisites, but it would be, the webinar would be fruitful if you had some experience with PMED and either the desktop or web versions for new pavement and rehabilitation design. And also if you have some experience with characterizing the existing conditions of pavement structure, just so some of the terminology and some of the screens and some of the discussions we have will make a little bit more sense if you have some prior experience. Certainly, if you have not had chance to use the software, you will still learn quite a bit as we go through this webinar. We'll talk about the rehabilitation design strategies in terms of recycling techniques in this webinar. We'll look at some of the assumptions and limitations for the different recycling options in this webinar. We'll talk about what kind of inputs we are using for the recycling options, and what were some of the decisions made in terms of those inputs. And we'll look at some of the results of different overlay recycling options, the rehabilitation options. So we'll look at some of the performance curves that come from each of these rehabilitation options, just to give you some idea of what are some of the impacts of these options have on performance. So just to give you an outline of the webinar, we have a quick introduction, just a handful of slides. We'll talk about recycling options, again, a few slides, and then we'll dive into the individual recycling design strategies and how they're used in Pavement ME Design. We'll talk about some summary and takeaways from the webinar, and then we will get into the Q&A session of the webinar. As an introduction, what I wanted to kind of talk about a little bit is to discuss the motivation behind including recycling options in Pavement ME Design. This enhancement was authorized by the task force because we get questions often from users and some confusion as to how to design rehabilitation projects when a recycling option is considered. For those of you who've had some experience using Pavement ME Design, you would have realized that you have to kind of start at a certain point when you're doing new design or rehabilitation design. And for example, if you have a stiff layer, you have a certain choices to make in the design procedure. And so there was some confusion and some questions in terms of what design path should I take in order to design a pavement if I'm doing a recycling strategy. And so the task force decided that we need to include this a little bit more in a streamlined manner so that a person who is using a specific recycling strategy does not go down the wrong path in terms of the design option itself. And so that was one of the motivations behind doing that. So as I mentioned, many users requested recycling options to be included as separate rehabilitation strategy, and make sure that there's consistent usage in terms of recycling techniques for rehabilitation design using Pavement ME Design. And then also some layer property assumptions. One of the things is when designs are being made with different recycling techniques, there are some layer properties that are needed for those layers, and some agencies have that information and others don't. And so one of the purposes of this effort was to actually provide some default layer properties for these recycling options. And some of this will become a little bit more clearer as I get into the rest of the presentation. So the objective of this 2024 enhancement, so this enhancement was done just very recently in the last fiscal year. We just started fiscal year 2025 on July 1st, 2024. So this was part of the last fiscal year. And the objective was to facilitate the use of recycling options that users can consider directly into the Pavement ME Design software for rehabilitation design. We'll look at the recycling options and what exactly I mean when we talk about recycling options. So that's the next few slides. So if you have an existing pavement And this could be a flexible pavement with or without an overlay. It could be a rigid pavement with an asphalt overlay, or it could be a rigid pavement without an asphalt overlay. These are the recycling options that an agency could consider. So the word recycling in this context is essentially doing something with that existing layer, or at least a portion of that existing layer, pavement layer, or one or more existing pavement layers, and putting it back in place. So that's kind of what recycling is, and that's how it differs from reconstruction in that sense. So we are focused on this left part of this chart. We are not going to talk about the rigid pavement without asphalt overlay rubberization. This feature was in Pavement ME Design even before we introduced some of these recycling options. So the rubberization portion is not what I'm covering today. What I'm covering today is this left part. So you could have a flexible pavement with or without an asphalt overlay, or even a rigid pavement with an asphalt overlay. And there are different options for recycling this. You could have a hot in place recycle, a cold in place recycle, a cold central plant recycle. And these first three are recycling options when you take portions of the top flexible layer. So that's what these first three are. And then the last one, the full depth reclamation, is you get into beyond the top asphalt layers and get into the subgrade or the base layers themselves. And so that's why that's not an option for the rigid pavement with asphalt overlay, because that would essentially be reconstruction if you get down and recycle that rigid pavement layer. So focusing on this for the flexible pavements. So when you have an existing pavement, our focus on the webinar today is on flexible pavements. We're talking about these as the recycling options, and I'll show some of these slides that go a little bit more in detail, but this is a good summary slide, and my friends at Road Resource have provided this information. They have a lot of good information on recycling, and some of the photos and slides that I have in this presentation are provided by them. So if you have an existing pavement, you could do a hot in place recycling. A hot in place recycling is where you take off the top 1 to 3 inches of the asphalt layer and just the asphalt material itself. And then you could overlay that by either a hot mix asphalt or a surface treatment. A cold in place recycling, you get a little bit more deeper, typically 3 to 5 inches, but not necessarily going through the entire depth of the pavement. You get to the partial depth of the pavement. Cold central plant recycling is basically very similar to the cold in place recycling. The only thing is you don't do that in place. You truck the material to a central plant, do some modifications and bring it back and then place it in on the pavement. And finally, the full depth reclamation, like I mentioned earlier before, you get deep, going through all the pavement layers down to the base, and then you essentially now have a base layer over which you would have typically an asphalt overlay, or if it's a low volume road, you might have a surface treatment. So we'll go into detail on each of these recycling design strategies. So let's start with the hot in place recycling and how it's used in Pavement ME Design. So with each of these treatments, I have a few handful of slides just to give you some background, and those who don't have experience with these recycling techniques, just to give some background on the recycling, each of the recycling techniques. So the hot in place recycling, the way that works is, and this impacts how we decide how that pavement layer is actually modeled in Pavement ME Design. So with a hot in place recycler, you heat and then essentially mill a small amount of that pavement surface. You may improve the properties of that recycled layer, and then you place it back in place and compact. So it's typically considered whenever a mill and fill or leveling course is needed prior to placing an asphalt overlay, and typically used for asphalt surfaces that do not exhibit excessive structural distress. So you really have most of the asphalt layer in pretty good condition. You have some surface distresses that you want to kind of mill and put back in place, and this is a good option for that. So as I mentioned, you heat the top few inches of the asphalt pavement to soften, and then once it's softened, you scarify that material. You add any rejuvenators and additives to improve the quality of that material. You mix and then place the mixture, and then you compact it. So essentially, you are really putting it's acting like a new asphalt overlay, the material that you just milled. The rejuvenating agents could be typically some kind of an oil or emulsion or binder. And the primary purpose is to improve the durability or fatigue performance of that layer. And typically you might add an HMA, you might add an HMA surface layer, or you may add some new aggregate to the mix to improve the gradation. And so you have a good quality mix, particularly if you are not going to do an overlay on top of it, and you're just going to do a surface treatment. You may add some new aggregate to the mix and add some additional bitumen or something to improve the quality of that mix. So there's different ways that this actually can be performed, many different options in which you do the hard-in-place recycling. You can have this process in single or multi-stage trains, and depending on the depth of how deep you want to make the treatment. If you only are going to a 1 or 2 inch depth, you would do a single hard-in-place recycling treatment. And if you have multiple layer, if you want to do significant depth, say let's say up to 3 inches, you may want to do several layers. Keep in mind you're heating and then scarifying an inch or so at a time. So the flow diagram for hard-in-place recycling strategy, as I mentioned before, a hard-in-place recycling, it is simulated as a new asphalt layer because you're taking it out, you're adding material to it and treating it almost as a new asphalt layer. So if you're treating it as a new asphalt layer, then there are different conditions under which this is applicable. If you have an existing pavement that's flexible, you could have an existing pavement that is semi-rigid. And if you recall, using Pavement ME Design, you have different calculations that are different models that are used depending on whether the pavement is designed as a flexible pavement or a semi-rigid pavement. Or you could even do it on an asphalt overlay of a rigid pavement. So let me start with this last one first. If this is rarely used because when you have an asphalt overlay of a rigid pavement, you could have reflection cracking. And when you have reflection, when I mentioned earlier that hard-in-place recycling is really a surface treatment of the layer. If you have reflection cracking, you are having distresses in the lower portions of that asphalt layer. So it's rarely used in that situation. So I'm going to focus on these two, the two on the left, the existing pavement flexible and the existing pavement semi-rigid. So you have an existing pavement that's semi-rigid or an existing pavement that's flexible, and you're doing a hard-in-place recycling. So it's designed as the first or multiple asphalt overlays of flexible pavement. So we are now going to treat this as an asphalt overlay. And then in the second case, we are going to treat this as an asphalt overlay of a semi-rigid pavement. So here's kind of a little bit of a summary of that. So if you have a hot mix asphalt overlay or even a ultra thin bonded wearing course on top of your hard-in-place recycle, Each of those layers are treated as an overlay layer, and the hot in place recycle layer is also treated as an overlay layer. So you have properties for those layers. If you are not going to have an asphalt overlay and an ultra thin bonded wearing course, and you're just going to have the hot in place recycle layer and then have a thin surface treatment or a micro, like a chip seal or a micro or slurry surfacing, or even just have the hot in place recycling as the wearing surface itself. Again, some of these are low volume roads, so you may decide not to have a surface treatment. Pavement ME Design will still allow you to use this as a surface overlay layer. So in this top case, you have two different layers, the HIR layer and the hot mix overlay layer, and in this case, just the HIR layer. So here are some screenshots for the hot in place recycling from Pavement ME Design. Hot in place recycling, you can see you start off when you do a new design and you start off with the general information. You have a new option here under design type, and it's called recycling. And then once you select the recycling design option, you will have many different options. I'll get to the FDRs and the CIRs in a little bit, but right now we're talking about the hot in place recycling, HIR. So you have hot in place recycling of AC over AC as an option, hot in place recycling of AC over AC. That means it's now of an overlay. So you're doing the hot in place recycling of an overlay rather than of a flexible pavement. An overlay of a flexible pavement rather than just the flexible pavement. Hot in place recycling of AC over semi-rigid, and then hot in place recycling AC over semi-rigid. Those are the options that we have for hot in place recycling. And here are some screenshots. Once you've made the selection, for example, you see AC over AC, and you can that you now have the pop up. Here's your existing structure, which is your layer 3 flexible default asphalt concrete. So this is your existing layer. And you've milled or hot in place recycled a portion of that, and that's this layer. And then if you do choose to put an asphalt overlay, you can have an asphalt overlay as this layer. So you have this layer is treated as a as an asphalt overlay layer, and then this layer is also treated as an asphalt overlay layer, and this layer is treated as an existing structure. So we are using the asphalt overlay design procedure of an existing structure in this case. As I mentioned before, you could actually delete this top layer and just have the hot in place recycling as your top layer. But if you choose not to do that and choose to have an asphalt overlay, then it will show these as your default layers. Obviously, you can change in Pavement ME the thickness of these individual layers. And you can also change the properties of these individual layers. There are, when you select this option, this layer 2 hot in place recycle has default properties that are typical of a new asphalt overlay default properties, or new asphalt material default properties. If you choose the AC over AC hot in place recycling, now you have your original structure, you have the existing overlay, you have the hot in place recycling layer, and then this is the new overlay that you've added on top of the HIR layer. So here's where you would, if you had, for example, and I'm just throwing this out there, if you have an original pavement layer, let's say it's an 8-inch asphalt, and then you had a 4-inch overlay on top of that, and you hot in place recycle 2 inches of that, and then put that in place. So you'd have two here for the existing overlay, 2 here for the hot in place recycling, and then here's the new overlay that you would add on top of that. So you essentially are now adding 4 inches of overlay on top of your existing overlay and your original structure. Similarly, when you have a semi-rigid pavement, so this is a hot in place recycling of a semi-rigid pavement. If you recall, using a semi-rigid pavement, it uses slightly different modeling procedures, and so you have a this is your existing structure, which is a semi-rigid pavement. You have your existing concrete pavement and the chemically stabilized layer that makes it a semi-rigid pavement. And if you hot in place recycle, say 2 inches of that, so you have a 2-inch hot in place recycle layer, and then you add a 4-inch overlay. Again, these are default values. You can change the thickness of this depending on exactly what thicknesses you choose to have. And there are default properties for each of these layers. And then finally, the fourth case of the hot in place recycling is when you do hot in place recycling of an overlay. So you have the semi-rigid pavement again, which is your existing asphalt concrete layer on top of your cement stabilized layer. And here's your existing overlay, which is which you take a few inches of that and put that into hot in place recycling. So now you have a hot in place recycling layer and a overlay that you've added on top of that, which is the default asphalt concrete layer. Again, these properties are the hot in place recycle layer is given the same assigned the same default properties as the asphalt concrete layer, and which can be changed by the user. So I think I mentioned this a couple of times. So the properties that are used for the hot in place recycle layer is the input level 3 material property equations for dense graded asphalt mixtures, which are assumed to be applicable for the hot in place recycle layer. And so because these are, that's the property, the dense graded asphalt mixture properties are used, the distress predictions are essentially the same as for asphalt mixtures that have the same aggregate binder and volumetric properties as a dense graded mixture. So you shouldn't see any difference if, for example, if I just change this to 4 inches of asphalt concrete, you shouldn't see any difference between that. So next we'll go into cold in place recycling and how that's used into Pavement ME Design. The hot in place recycling is a little simpler simply because the hot in place recycle layer is treated like a new asphalt layer. So that's really the main feature of hot in place recycling. But when we get into cold in place recycling and full depth reclamation, things change a little bit because we now have different categories or classes of this. So let me get into some of the details of cold in place recycling. As I mentioned earlier before, cold in place recycling is a technique where you cold mill some of the asphalt layer, as I showed in an earlier slide, about 3 to 5 inches. Then you would improve the properties of that recycle layer, place it back in place, and compact it in place. It's a really good technique that's typically used to address severe distresses in the top lifts or even reflection cracking. But if you have significant structural, especially bottom-up cracking, it may not be suitable in that situation. But for the most part, it's a really good technique that assumes that you have decent structure in the lower part of the existing asphalt concrete. So the process is cold mill the top few inches of the asphalt pavement, add the recycling agents and additives, aggregate. again, that the second bullet is primarily to improve the quality of that layer, and improve the quality can mean a lot of different things to a lot of different people. You can improve it to a small extent, or you can improve it to a significant extent, depending on what you're going to do after that. That means if you're going to place if you're going to use it mostly as a base course, then you may not substantially improve the quality of it. But if you're going to use it as a good quality pavement layer, you may want to add some additives and aggregate and so on. So once you do that, you mix and place the mixture, and then you compact the mixture. Many different agents are used for this purpose. You could have bituminous agents, foamed asphalt, emulsified asphalt. You could have many chemical additives, cement or lime, to add to this mixture, and which can be used for some early strength gain and resistance to moisture damage. You could add new aggregate to improve the mixture properties, and then before putting it back into place. So many different ways to improve the quality of this mixture before putting it in place. Again, there's this presentation is not necessarily about the techniques and so on, but I thought it would be good to show a few basic slides on this, just to give you an idea of what these are. Different types of cold in place recycling trains exist depending on what is the feature of that mixture that is needed, and what quality you want. So you could remove the material, add the recycling agents, mix and control, and then so all of these will define the equipment that you would use to perform this treatment. If you have cold in place recycling, it gets a little tricky compared to hot in place recycling, because now we have many different options. So let me kind of go through this one at a time. So you have a cold in place recycling strategy. The designer has to decide what kind of cold in place recycling have I planned for this project, and depending on that, the user has to decide what that strategy is going to be, and then Pavement ME Design will model based on that strategy. So let me start here on the right. The recycle layer responds as a dense graded asphalt layer. So this is a situation where you add bituminous material to the cold in place recycle, and you improve the quality of it to where it acts as a stiff layer. And so it's simulated as a new asphalt layer in this situation because it has sufficient stiffness. So depending on what material we use, this layer is treated as an existing flexible pavement, or depending on whether you have an existing flexible pavement or an existing semi-rigid pavement, it's designed on an asphalt overlay of a flexible pavement or an asphalt overlay of a semi-rigid pavement. So it depends on the situation, on what is the underlying layer and the existing pavement, whether it's flexible or semi-rigid. The models will choose the path for that. But the key is that your top layer, your cold in place recycle layer, is treated as a flexible pavement layer or a new asphalt layer. So this item is the key here. If there isn't enough binder in the cold in place recycle, so now you have a situation where it responds as an unbounded layer. So really an unbound layer so there are different situations here. Again, if you don't have any additive in the cold in place recycle layer, you have a minimum amount of bituminous additive in the cold in place recycle layer, or a minimum amount of cementitious additive in that layer. So each one of these have different default properties that is included in Pavement ME Design depending on what is used. As I show some of the screenshots, some of it will become a little bit more obvious. But here the cold in place layer is simulated as an aggregate base. So that's the main difference. Their difference between the right side and the left side is how that layer is treated, whether it's treated as a new asphalt layer or whether it is treated as a aggregate base. So here's the tricky part of this. So because Pavement ME Design, we can't have a cushion layer in Pavement ME Design. The model for the existing asphalt layer, the layers that are beneath the cold in place recycle layer, in this case, is also simulated as the unbound layer with the high modulus, because we don't want to have a treated layer and then a granular layer and then a treated layer underneath it. So the layer underneath it is treated as an unbound base with a high modulus. So this responds as an unbound layer, and then here it responds as an asphalt layer. So Pavement ME Design allows for different options here. So cold in place recycle with class A is designed and constructed as a dense graded layer. So class A is when there's sufficient binder or additives that have been added to the CIR layer. So it responds as a bound layer. It has tensile or flexural strength that will resist tensile stresses or strains. So this kind of summarizes what I've been saying, in that if you have this situation, it responds as an asphalt layer. And the only difference between A1 and A2 is when the stabilization material is emulsified or foamed asphalt, different default properties are entered. And then when the stabilization material is a cementitious material, different default properties are provided. Class B, on the other hand, there's only a minimum amount of stabilizer material has been added. And so it responds as an unbound aggregate layer. In the modeling, it's modeled as an unbound aggregate layer with a representative annual resilient modulus. I mentioned this before, but it's worth repeating here again. There's default values that are included for this, but a user who has better test data or better values for their agency can change those values for their design purposes, but their default inputs. If you select a class B cold in place recycle, the default values will be loaded for that layer. And then finally, class C is where there is no additional stabilizer material is added. So the layer responds as an unbound aggregate layer. And in this case, the resilient modulus is dependent on water content that changes over time. So the difference between class B and class C is lower in modulus than class B, and then class C, the modulus changes with the moisture content of that layer, versus in class B, it's essentially kept fixed over time. So here are the options for the cold in place recycling. So you have a new asphalt wearing surface. You would have a cold in place recycle with an asphalt overlay or some kind of ultra thin bonded wearing course. So in which case the cold in place recycling layer will have certain properties, and then the asphalt overlay will be treated as an asphalt overlay design. If there is no new, this is relatively rare, but if you do a class A, that means you've improve the properties of that cold in place recycling layer, you may choose to just have no asphalt wearing surface and just do a chip seal or a micro or something like that on top of that cold in place recycle layer. And so in that case, the Pavement ME Design will still allow you to model the cold in place recycling layer as a top layer with lower properties than a new wearing course. Now, if you do not have a wearing course and do a Class B or Class C, that's not allowed in Pavement ME Design software because we cannot have essentially a unbound material as the top surface of the pavement layer. So this last option is, and I don't know if anybody actually does a cold in place recycled Class B or C with just a thin surface like a chip seal or a micro on top of that, but that's not allowed in Pavement ME Design. So as I mentioned, in most cases of cold in place recycling, an asphalt overlay is placed above Class A cold in place recycling layer, but you can remove that overlay and still run the design as the CIR layer as being the top layer. Asphalt overlay above Class B and C are needed. If you have Class B and Class C, you do need the asphalt overlay on top of that in order to run the design. However, when you use Class B and Class C, keep in mind that we cannot model a sandwich layer. So the remaining asphalt layer beneath any of the existing asphalt layer that you do not mill and cold in place recycle is assigned the same layer designation as the cold in place recycle layer. So here are some of the screenshots for this. You have cold in place Class A1, cold in place Class A2, cold in place Class B, cold in place Class C. Again, depending on the choices you make, the default values for those will be populated for those individual layers. So here's a screenshot for the cold in place recycle Class A1, and you can see you have the new overlay that you add that's defaulted to 4 inches. Of course, you can change that thickness. Here's your cold in place recycle layer that is populated at a default of 4 inches and it's populated with some default properties. And then here's the existing structure of the existing default asphalt pavement. Here's the same, this is a situation with the semi-rigid pavement. You have, here's your new cold in place recycle layer. Here's your new asphalt overlay, and this is a semi-rigid pavement case. And you have your default asphalt concrete layer and your semi-rigid pavement. So you can have a semi-rigid situation for the cold in place recycling as well. Here's the Class C for cold in place recycle. Here's the overlay that you've placed on top of the cold in place recycling layer, and here's the existing layer, the cold in place recycle. It's modeled as a this is the existing asphalt pavement, but as I mentioned before, it is modeled as the cold in place recycled layer because we cannot have a sandwich layer. And here's the cold in place. Sorry, this is Class C. Sorry, and here's the cold in place Class B. You have the cold in place recycle layer that's treated as a non-stabilized base, and the overlay is added on top of this. So this is how the whole layer is treated as a non-stabilized base. So here's some runs, some design runs that Harold did, and give credit to Harold for running a lot of these design runs and developing these protocols for the cold in place recycling and the full depth reclamation and the hot in place recycling. So um, this is just an example. Again, individual cases will be different, but the next few slides are, you have to run some example. If here's when you have an 8-inch asphalt layer over a 6-inch crushed stone base and subgrade soil of A6. You have cold in place recycle without additives, and then cold in place recycle with additives, and bituminous or pozzolanic additives. 2 inch asphalt layer, 4-inch cold in place recycle mixed in place, and then on top of the existing 4-inch, as I mentioned before, this is modeled as a crushed stone with a representative modulus of 75,000 psi in this case, and then here's your crushed stone. So if you so let me start with the rutting, and if you have the baseline design has this level. If you don't have any additives, you have higher level of rutting. If you have a minimum amount of additives, you have um, the bituminous additive, you have this level of rutting. And if you have pozzolanic additives, it's a little better. So in at age 20, you're going the crushed stone base. Obviously, this is your dense graded design with the crushed stone base has the lowest rutting, and the cold in place recycling has a little bit more rutting depending on the amount of additive. And if there's no additive, then the rutting goes up from, let's say, about 0.23 or so to about 0.33 or so. So a little bit more rutting after 20 years with the cold in place recycling, as opposed to essentially a new asphalt pavement for the same thickness. The bottom up fatigue cracking, again, if you have no additive, there's quite a bit more bottom up fatigue cracking. But if you have some amount of additive in the cold in place recycling, in this case, the bottom up fatigue cracking was pretty low. Top down fatigue cracking, the baseline crushed stone base and the no additive had more top down fatigue cracking, and then the bituminous additive, and with the additive, the amount of fatigue cracking is reduced by about half in this case. Typically, cold in place recycling is done with an additive. So the last one was just without additives. So essentially, the cold in place recycling is treated as a granular layer. With an additive, it is treated as a flexible layer. So again, comparing essentially a new pavement design with a cold in place bituminous additive and a 2-inch asphalt overlay. For you have 4 inches of cold in place and 4 inches of existing asphalt layer, or 6 inches, and an A6 soil. So the default asphalt layer, so this is the new design, has a rut depth of about 0.1. With the high, with depending on the stiffness of the cold in place recycle layer, if it's a high stiffness cold in place recycle layer, you have rutting of about 0.2, and then when the cold in place recycle layer has a lower stiffness, you have a higher amount of rutting. So depending on how much additive you use, you can have different levels of rutting. Here's the bottom-up fatigue cracking model. Again, there's not that much difference between these three on this domain for any of the different layers. So they are about the same at age 20. And the same thing with the top-down fatigue cracking. So rutting was the only major difference for this when additives are used. So that was cold-in-place recycling. Let me get into full depth reclamation and how full depth reclamation is used in Pavement ME Design. Talk a little bit about full depth reclamation. Full depth reclamation is a situation where the entire thickness of the asphalt is pulverized and combined with most of the underlying layers, and it's essentially creating a stabilized base layer. And depending on how much binder or additive is used, the properties of that layer can change. It's kind of very similar to what we discussed with the cold-in-place recycling. And it's typically used when your flexible pavement has extensive structural distress. So you're really recycling pretty much the entire asphalt layer and including some of the base layers in place. So you pulverize and mix the asphalt materials and some of the underlying materials using a reclaimer or recycler. You add a stabilizing agent and additives, and then you compact and grade the material. So you've created essentially a new base course over which you place the asphalt overlay. You could do different types of stabilization of that layer, add new aggregate or wrap or other recycled aggregate, and change the gradation. You could increase the thickness of this layer to or do certain things to meet performance requirements. You could have different types of stabilization, chemical stabilization. There's a whole host of chemicals that can be used in full depth reclamation. Or you could also use emulsified asphalt or foamed asphalt to stabilize this layer. So there's many different options that are available. So very similar to the cold-in-place recycling, the full depth reclamation rehabilitation strategy, again, depending on whether that recycled layer is the designer has to choose how this layer will be constructed. Again, we have the same options, the A1, A2, B, and C for defaults, and then the B and C is where the recycled layer responds as an unbound layer, and the A1 and A2 is where the recycled layer is responds as a bound layer. So it's designed as a dense graded bituminous mix. If or a chemically stabilized material. If it's a chemically stabilized material, it's designed as a new semi-rigid pavement. If it's bituminous material, it's designed as a new flexible pavement. The full depth reclamation layer is simulated as an asphalt layer in this case. The full depth reclamation layer is simulated as a chemically stabilized layer in this case. If it's unbound, the FDR is designed as a new flexible pavement. The FDR layer itself is simulated as an aggregate layer. And then depending on whether there's additives included, the properties of that additive, that FDR layer is a little different. So some of this is very similar to the cold-in-place recycle, whether it responds as an unbound layer or a bound layer. So you will always have an asphalt wearing course for a full depth reclamation. So you have to have at least 1 inch for the simulation. So you have full depth reclamation plus asphalt overlay. And as I mentioned, the full depth reclamation or an ultra thin bonded wearing course you would have as the surface layer. If you don't have a wearing course of full depth reclamation is not considered in the Pavement ME Design software. So similar to the cold in place recycle, Class A full depth reclamation responds as a bound layer, when I say bound layer, it means it has tensile or flexural strength to resist tensile stresses or strains, and so it depends on whether it is asphalt stabilized Class A1 or cementitious stabilized Class A2. Class B is when you have minimum amount of additive added, so it does increase the modulus a little bit, but it does not have enough strength to resist the tensile stresses or strains, and so it responds as an unbound layer. But because it has reasonable level of stiffness, it acts as a good quality base material with the representative annual resilient modulus. And finally, Class C is no additive or binder added. So really it acts as almost as a high quality subgrade layer or granular layer. And it responds as such with the resilient modulus dependent on water content that changes over time as modeled using the climatic model that's included in the software. Again, the screenshots are very similar. You have to select the recycling option, and then you have the different full depth reclamation options. So here's your new asphalt overlay that you add on top of the full depth reclamation. This is Class A1, and so the default properties are that of a bituminous layer. Here is full depth reclamation with Class A2. So the default properties are that of a chemically stabilized layer. And so the modeling then uses the chemically stabilized modeling. The Class B is, again, you have a non-stabilized base, and the full depth reclamation for Class B is, as I mentioned before, you have your asphalt overlay, and then it's treated as a granular layer with a high modulus. And then finally, Class C is treated as a granular layer, but the modulus of this is also pretty high, but it will change with the water content in that layer. So here's some design examples. And again, to compare this, if you design a pavement with the 2-inch asphalt layer and 10-inch, this first set is for full depth reclamation without or just a minimum amount of additives. So you have without additives or minimum amount of additives, which is bituminous or cementitious. You have an existing layer modeled as 2 inches over 10-inch crushed stone aggregate, and then 8 inches of coarse grain subbase, and then A6 soil subgrade. And here we have this model with a 3.5-inch asphalt overlay, 6 inches full depth reclamation, and 6 inches of crushed stone. As I mentioned before, without additives, the full depth reclamation layer is modeled as a granular layer. So here's the results. So for rutting, again, the baseline crushed stone base has a little bit lower rutting, and then when you have no additive in the full depth reclamation layer, it has a little bit more rutting at 20 years. When you have some additives, bituminous or cementitious, it's kind of comparable to this baseline design case. Likewise, for bottom-up fatigue cracking, here's the baseline crushed stone. Now, in this case, the baseline has a little bit more bottom-up cracking compared to the full depth reclamation layer. When you add the bituminous additive or the cementitious additive, the bottom-up cracking is pretty small in this case. The top-down cracking here is pretty high for the baseline case, but for the additives case and the for the full depth reclamation case, the top-down cracking is lower. Like I mentioned before, when there's no additives used, the full depth reclamation is simulated as an unbound layer, and the resilient modulus is dependent on the degree of saturation as predicted by the Pavement ME Design software. So you can see that the modulus is changing over time, seasonally, for this layer. Typically, if you do full depth reclamation, it is with additives. And so here's some example. The default or the baseline case is 2 inches of asphalt layer over 10 inches of stone. And then with the added, and then here's the full depth reclamation, 2 inches of an asphalt overlay. Again, this is just for comparison purposes. They don't necessarily mean that this pavement is a replacement or identical to this, but it's kind of close enough. Over 7 inches full depth reclamation, and then 5 inches of crushed stone aggregate base, and then A6 soil as the subgrade. So the baseline model shows a level of rutting of about 0.25 inches. With the low stiffness, we have a little bit higher rut depth, and then if you change the stiffness to a high stiffness bitumen, that rutting drops down. Top-down fatigue cracking, because the top layer is essentially a new layer, the top-down fatigue cracking is not impacted by the full depth reclamation layer, so it's the same top-down fatigue cracking. And then the bottom of fatigue cracking, again, because the properties are different for the different layers. The baseline has a lower bottom of fatigue cracking, but the full depth reclamation layer, when it has low stiffness, it has the higher level of bottom of fatigue cracking, and when you increase the stiffness, then it has a higher level of bottom of fatigue cracking. So the total, which is the new and reflective fatigue cracking for this, here's the baseline case. For this is the chemically stabilized example. So when you have the chemically stabilized layer, we have some reflection cracking and some fatigue cracking. And so that total cracking for the baseline case is lower when you have a lower strength cementitious material. You have a higher level of cracking, and then if you have a higher strength cementitious material, you can match the baseline cement stabilized layer design. So just a quick summary of this process. The Pavement ME Design now has new recycling strategies, which are hot in place recycling, cold in place recycling, and full depth reclamation incorporated into Pavement ME Design. The analysis path that by Pavement ME Design depends on the layer types and the strategies, including the amount and type of additives. So as I mentioned before, depending on whether you do class A or A1 or A2 or B or C, there's different default values that are provided in Pavement ME Design, but also the analysis path taken within Pavement ME Design is different. Because the analysis paths are different, the calibration coefficients are different for these different paths. So now the user does not have to think about which option to choose while selecting a recycling strategy, and you can choose the built-in HIR, CR, FDR options and use that as you're performing your overlay recycling overlay design. So that's all I had for the presentation. I'm sorry I could not catch all of that, all of the Q&A, but we'll get to that in a little bit. Ben, did you say you wanted to do the second poll, or?
Yes, I'll watch it right.
Okay.
All right, looks like we've got everyone that could participate in the poll in. So continue on, Sri.
Thank you. So just a few more things before we get to the Q&A portion. The local calibration guide is the next webinar. And I believe John Donahue will present on that. And that's planned sometime in the first quarter of the new calendar year. And then back calculation tool webinar is planned for the second quarter of the calendar year 2025. So stay tuned for information on those webinars, and you should see some emails to register for those webinars once the actual dates have been set in stone. Reminder that slides, Q&A, and recording can be found on Pavement ME Design homepage, and then also on the YouTube channel, AASHTOWare YouTube channel. So one note on the bottom, we're always looking for webinar topics, and we have a kind of a rolling list that we maintain, and sometimes we repeat some themes because some small changes have been made. So if you have any suggestions for webinar topics, please send them to us, and we'd be very happy to present webinars on those topics. So let's get into the Q&A session.
Sri, most of the questions Harold answered, only few left actually. Um,
Okay.
So one of the question is, can all the same calibration coefficient for both local and global can be used with only potentially changing or updating the red dot coefficients and fatigue cracking coefficients? I think it's basically asking, can we use the same calibration coefficients?
Yeah, the idea is not to change calibration coefficients. The the idea is to change the material properties, and what we for the so I would suggest that if you would do anything, instead of using default properties, you use specific properties for these layers in your agency. But once you have the specific properties, uh, the modeling itself should still be correct with the original calibration coefficient. So I don't think you would need to recalibrate anything, but you certainly want to have agency specific properties for these layers. The default properties are good, and I think that's a really good starting point, but on the material properties are more important than the calibration coefficient. So you would most likely not have to recalibrate.
So see, but if an agency has a lot of sections, let's say for FDR, can they still locally calibrate based on their performance?
I would certainly, I wouldn't think, I can't see why not. Yeah, if you have a lot of FDR, CIR sections, and you think there is value in recalibrating that as a separate group or separate category of payments, you can certainly do that. I don't expect to see that much difference, but maybe there can be, I don't know.
Yeah, yeah. I think one more question. I think Harold is typing the answer. Um, uh, so for FDR, CAR Class C, you are assuming the same sieve inputs. I'm assuming it's a gradation, sieve inputs as used for crushed stone. It's asking, are you using the same?
Yes.
Yeah.
Yeah, it's modeled. I think the sieve inputs. I need to check on this, but I think it's modeled as an A1A. It's using the same gradation as an A1A crushed stone base. Now the question is in terms of why. That's a starting point for that. I mean, clearly, if you have better data for your um, that's the default. If you have better data, you can certainly override the default values and enter that. In terms of why, as part of this project, ARA, as led by Harold and a few others, kind of combed through available data of existing CIR and FDR, and use that data to develop the default values. So some of the default part of it was there just wasn't a lot of sections to provide, especially LTPP type sections and sections that had good quality data. So so it was based on the amount of information that was available. The default values were established based on that. It if you have better default values, I would set it at that different value. But this was just based on the available data. The choices were made for the defaults.
Thank you, Sri. I think we answered all the questions that are in the chat box. I don't see anything new. Yeah.
All right.
All right.
Well, thank you to our presenters and our moderator, Hari and Sri. We really appreciate it. Like Sri mentioned, the recordings will be found later on AASHTOW TV. Go to transportation.org, AASHTO TV, and you can find the AASHTOWare Pavement ME Design channel. Any webinar topics you'd like to see, feel free to reach out to any of us and provide suggestions. So have a good rest of your day and a happy holiday season. Thank you all so much.